Prove that divergence of vector function a plus b is equal to divergence of a plus divergence of b. This is one property of divergence, and we know divergence is always operated on vector function or vector field. Divergence of a vector function can be written as del dot the vector function. That means div a plus b is equal to del dot a plus b, and that is equal to div a or del dot a plus div b or del dot b. We have to prove del dot a plus b is equal to del dot a plus del dot b. This is one property of divergence. Let the vector function a equal to, or a vector is equal to I cap ax plus j cap ay plus k cap az. The vector b is equal to I cap bx plus j cap by plus k cap bz. So vector a plus vector b, if you add the two vectors, then that will be equal to ax plus bx into I cap plus ay plus by into j cap plus az plus bz into k cap. So the divergence of a plus b, which is equal to, which is called the dot product of del dot a plus b, that is equal to, you can write del operator as I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z dot a plus b. Here you can write also divergence of a plus b, which is equal to del dot a plus b, and this is your del operator dotted with a plus b. Here a plus b is equal to this vector. So if you take the dot product of this del operator with this vector, then only you have I dot I, j dot j, k dot k. So you have partial derivative of ax plus bx with respect to x, which will be equal to partial derivative of ax with respect to x plus partial derivative of bx with respect to x. Similarly, for this term, that is jth term, you have partial derivative of ay plus by with respect to y, which will be equal to partial derivative of ay with respect to y plus partial derivative of by with respect to y. Similarly, if you take the dot product of this vector with respect to z, first to find out the partial derivative, then take the dot product, then that will be equal to partial derivative of az plus bz with respect to z. So that can be written as partial derivative of az with respect to z plus partial derivative of bz with respect to z. So if you simplify it, you take the a term this side and b term this side, terms this side. So this will be equal to partial derivative of ax with respect to x plus partial derivative of ay with respect to y plus partial derivative of az with respect to z plus partial derivative of bx with respect to x plus partial derivative of by with respect to y plus partial derivative of bz with respect to z. So after rearranging the term, this one is equal to the del dot a. Del dot a will be this one and del dot b will be this one. So this will be equal to del dot a plus del dot b. So in this way you can prove that del dot a plus b is equal to del dot a plus del dot b. This one. Del dot a plus b is equal to del dot a plus del dot a plus b. So this is nothing but divergence of a plus b is equal to divergence of a plus divergence of b. This is one important property of divergence. So in the examination, you will be asked to prove divergence of a plus b, or prove that divergence of a plus b is equal to divergence of a plus divergence of b, where a and b are vector functions.